Yes. Today your final mock now. Yes, I am right. I'm audible. आपकी वॉइस नहीं आ रही वॉइस.
सर वॉइस आ रही है अभी?
यस, अब आई आवाज. यस.
ठीक है सर. टुडे ऑर्गेनोमेटेलिक लेफ्ट पार्ट and tomorrow will be the final mock.
कहाँ तक डिस्कस किया था हमने? ओएमसी.
सर मेटल क्लस्टर से आगे तक हुआ था. मेटल क्लस्टर से बाकी है. फ्लक्सियनल बिहेवियर तक हुआ था.
मेटल
मेटल क्लस्टर से आज
क्लस्टर. यस. होमोजीनियस हेटेरोजीनियस कैटालिस्ट हो गया था कि नहीं?
जी सर हो गया.
यस, आज हम डिस्कस करते हैं होमोजीनियस कैटालिस्ट या हेटेरोजीनियस कैटालिस्ट. व्हाट द डिफरेंस?
यस सर. होमो होमोजेनस heterogeneous. So homogeneous catalysts are sir the catalysts are in same phase, whether solid, liquid or gas, as with the reaction substrates. On the other hand, sir, heterogeneous catalysts are those whose phase are different from the reaction mixture or reaction substrates. So this is the basic difference between homogeneous and heterogeneous catalyst.
Yes, what the example of
So for
homogeneous
homogeneous
catalyst?
catalyst, there's Grubbs first generation catalyst, first gen catalyst, that is RHPCY thrice PCY thrice chlorine double bond PH. This is Grubbs first gen catalyst. This is a homogeneous catalyst. Heterogeneous catalyst. हेटेरोजेनस तो हेटेरोजेनस का भी याद नहीं आ रहा है एग्जांपल.
But a hard formulation of alkenes
Oh,
catalyst. मतलब main application of hard
oh,
formulation of alkene.
okay, sir. CO2 CO halide. This is the catalyst for hydroformylation, and there some there plus there some be some iodide promoter. Mm. So this is the and the active form of this is that involved in the reaction is HCO CO whole 4. This is the active form. This is the example of hydrogen scaling.
Yes, what is Baker process? Explain what the Baker process. What the main application of Baker process?
The Waker process is a reaction that generates Waker process. So from alkene to acetaldehyde. The industrial formation of alkene to acetaldehyde is called Waker process. In this process, we need half O2, and the catalyst that is used here is PdCl4 2 minus, and co-catalyst is used is CuCl2. The co-catalyst CuCl2 is used to revive PD0 uh, to revive PD from PD0 to PD2 plus. So this is called Waker process.
Yes, good. What is olefin metathesis?
Yes, sir. Olefin metathesis. So if I have R1, R, R1, R1, and R1, there is two type of alkenes with different substituents. Here R2, 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 and R2. So if I use in this reaction, if I use a shock carbon complex or a Grubbs first gen or second gen catalyst. So we get and their they rearrange themselves in different ways and give rearranged products like R1, R1, R2, R2, and their original ones also. This is the rearranged product, and if I say this is A and this is B, so also A and B. So this rearrangement of uh, substituents is what we call olefin metathesis, and mainly shock carbons and Grubbs catalysts are responsible for this type of olefin matrices?
Any example?
Yes, sir. Mm, and metal Ln double one C and R dash 2. So this is like C C L L C R dash 2. So the bond now this bond between carbon carbon breaks and they form a new bond C H. So here R H C double bond M L N. Here is MLN is the metal complex or Grubbs catalyst or Strock carbene complex, and this is the new generated carbene. This is the mechanism or example.
Yes. What is coupling reaction? What the difference between coupling and cross coupling reaction in OMC? Explain.
So coupling reactions are basically the formation of carbon-carbon single bond in the such reactions. As for example, Heck reaction is an example of Heck reaction or Stille coupling. Stille coupling is an example of coupling reaction. On the other hand, the cross coupling is it is also a coupling reaction, but here uh, coupling between from one metal carbon complex with another metal carbon complex. So the example is example of this type of reaction is sonography.
Yes. What is polymerization? What the difference between polymerization and oligopolymerization? Explain briefly.
सर वो पॉलीमराइजेशन वाला पार्ट नहीं पढ़ा नहीं है वो चैप्टर पढ़ा है
Ferrocene. What is ferrocene? What the main application of ferrocenes?
तो फेरोसिन Ferrocene is a sandwich compound where two CP ligands CP ligands are placed one above another between them a key atom reside. So the general representation of ferrocene is Cp2Fe, and if I draw the structure, so this is ferrocene, and number of electron count, if I mm, 5 electron contribution, Fe is 8 and it is also 5, so total 18 electron complex. So it follows the 18 electron rule. So it is stable and it is yellow in color.
Yes, uses of ferrocenes. How many types of ferrocenes?
Yes. So this structure mainly explains the fully eclipsed ferrocene. So the uses of ferrocene. So the main use of ferrocene is as an anti-knocking agent, anti-knocking reagent, and also anti-knocking reagent in um, fuels like uh, diesel, and also it uses that catalyst. These are the main uses.
Yes. What the relation between CFC and ferrocene? And yes, first of all, crystal field energy. Next point is what the relation between ferrocene and NMR, shielding, deshielding effect.
Yes, sir. Crystal field energy. So if I draw the diagram, molecular orbital diagram. So as I can see the diagram, the main orbitals involved is so so this is E2, this is A1, and this is E1, and as the number of electrons in ferrocene is P2 happen. So electron there are 6 electrons. So
Yes. Next, what the effect of NMR shielding deshielding effect in kerosene system?
so in kerosene there are the electrons.
Yes.
So due to the field, the so these are the electron. Uh, this is the direction of external electric field, external magnetic field, and this magnetic lines are parallel to this. So the effective external magnetic field or the effective field increases. So this hydrogens in NMR spectrum are deshielded. So they have high CP value, high delta value.
Any limitation of kerosene?
Limitations. सर लिमिटेशंस पता नहीं.
लिमिटेशन मैंने ग्रुप में सबकी भेजी हुई है जो आपके टॉपिक है. आपके टॉपिक कौन से हैं? केमिकल काइनेटिक्स, गैसीय स्टेट, थर्मो ओएमसी और
Single sir.
स्पेक्ट्रम. मैंने भेज
Yes.
दिया है, सबकी लिमिटेशन पढ़ लेना. ठीक है.
Yes sir.
What is the difference between flagellity in OMC, flagell behavior in organic metallic compounds? What the effect of these one from temperature, pressure? Explain.
Oh, okay sir. So fluxionality and Taking an example, this is the eta 5 CP, and it is an example of 18 electron complex. Now this is in eta 5 CP state, and during reaction it shows eta 1 CP or eta 3 CP. So if temperature is low or temperature is decreased, then the fluxional behavior of this CP ligand, fluxio behavior, will decrease. So at low temperature, and the each hydrogen will be different. So we get the NMR value of each hydrogen of the equivalent hydrogens, each equivalent hydrogens. So equivalent hydrogens will be showing different values, whereas at high temperature, the hydrogen will show only a single value due to high fluxionality.
Yes. Yes, what the difference between associative reaction and dissociative reactions in OMC? What the uses?
Yes, sir. So associative reactions, in this the ligand, the new incoming ligand associate first, then the leaving ligand leaves. So in this case, there will be ML5 L dash. So ML, so there will be like L dash. So after that there will be dissociation L dash. So M L dash, there will be this type of association. first the new ligand attached with the metal, then the ligand leaves. And in this case, as number of substrate in the reactant side is high or greater than that of product side, so due to association delta S will be negative. So the delta H will be highly negative. So this will be a exothermic reaction. On the other hand, uh, in dissociation, so in dissociation, let's say Ml6, so the leaving ligand leaves first, so this become Ml5, and after that the new ligand attaches to the metal, forming the Ml5 L dash. So in this case, plus L. So in this case, delta S is not negative. So this is the difference between the associative reaction and dissociative reaction.
Yes. What is symmetric asymmetric synthesis in OMC?
The asymmetric synthesis mainly follows with chiral uh, ligand in catalyst list plus achiral substrate forms uh, a stereoselective product. Stereoselective product. So this type of reactions are called asymmetric synthesis. An example of this is uh, formation of L-dopa or L-dopamine, that is used in the uh, cure of Parkinson disease. So the reaction is so metal di equal to positive and this me double bond COOH NH OMe. This forms COOH dot H NHM OMe, and by hydrolysis this forms NH2 hydrogen COOH. So this is L-DOPA, and this forms this enhancer selective product forms 97.5%, and the yield of this product is 100%. Of that, the enantiomeric excess of L-DOPA is 97.5%. So this is called asymmetric synthesis of inorganometallic chemistry.
Yes. What the uses of OMC in our society, real life, human being?
So organometallic chemistry in our mainly main uses of organometallic chemistry is in the industrial field, where we have to prepare prepare acetic acid is a daily that is a needed product from methanol by Monsanto process. Then we can get the oxidized by the Wacker process. We can get the acetaldehyde in that is used in our labs. Wacker process. So CH2 half O2 CH3CHO. Alongside this, can be vinyl acetate can be formed. That is high industrial use by this Wacker process, and also hydroformylation is used in many, and are coupling reactions. There is L-DOPA, and that is the Parkinson disease medicine for Parkinson disease. L-DOPA preparation. There are coupling reactions like Hague reaction. So in the medicinal field, there where carbon-carbon bonds are needed. So coupling reactions play a greater role in that reaction. So Hague reaction, Sonogashira. Chile coupling, Negishi coupling.
Yes, yes, good. Yes, good point. Next point is what the limitation of OMC? Explain briefly limitation.
So the main limitations is the organometallic chemistry, the waste products that the waste product that are created during the reactions. Then there are many costly metals that are used, like ruthenium in many reactions. So these are highly cost. So the reaction organometallic compounds are not